Okay, so for the last two examples for today, we're going to see this first example where it's y equals 3 cos 2x. So those multipliers, the 3 and the 2, the 3 is going to be stretching this graph vertically, and the 2 is going to be halving the x values. It's going to be a horizontal compression. So we are going to take the cosine parent function, and we are going to vertically stretch it by 3. Remember, whatever we do to the x is the opposite of what we think, so we are halving the x values, which is a horizontal compression. Okay, so we're taking the cosine graph. So here we're not shifting any, so let's do this the same way we did the last one, where we take each data point and look at what's happening. So the cosine graph, if you remember here, one of our points is at 0, 1. So when we talk about, the vertical stretch would just be taking this and stretching that by 3, stretching this one by 3, because your y value here is 1. Well, if I triple it, I'm at 3. Here my y value is 0. If I triple 0, I'm still at 0. So that 3 is just going to stretch these y values down and make our graph look like this. Okay? But we also have that 2x. So what does the 2x do? That's halving the x values. So our x value is pi over 2. Well, if I cut that in half, that really becomes pi over 4. If I cut pi in half, that's pi over 2. So we're taking these x values and cutting them in half. So let's see what that looks like. So the first point on our graph was 0, 1. So it's like right here for cosine, because again, you always got to make sure which graph you're looking at. If I stretch this point by 3, I fall right here. Stretch the y value by 3. And then if I halve the x value, well, my x value is at 1. I'm sorry, my x value is at 0. If you half 0, you're still at 0. So that point is going to stay right here. Next point, we were right here. And this was originally pi over 2. So let's see what that looks like. If I were to vertically stretch by 3, at this point, my y value is 0. Well, if I triple 0, I stay there. So I've taken care of that. Then I half the x values. Well, half of pi over 2 is really pi over 4. So it's going to become pi over 4. And that stays where it is. So I can just make that a point. The next point that was on our graph was right here. And it was originally at pi. So if I take that point and I vertically stretch it by 3, well, I'm sitting at -1. If I triple -1, I'm at -3. So I would fall right here. And then I have to half what that x value was. So it becomes pi over 2. So all we're doing here is changing this x-axis to be half of what we originally labeled with the parent function. So we had pi over 2, pi. 3 pi over 2 is going to become 3 pi over 4. And then half of 2 pi is pi. Those ordered pairs I had there are just being stretched by 3. Well, this point was originally sitting right there at 0 for the y value. So if you triple 0, you stay at 0. This point was sitting at 1. If I stretch that, I'm sitting up at 3. So while we really didn't see this horizontal compression because we just relabeled the number line, it is in fact compressed horizontally. So let me just label this way and continue that pattern. So we were up at the top, so I have to go through the middle, back to the bottom, through the middle, back to the top. These arrows have to be curved back down. So we need arrows on our graph. If you make it go like that, that's not where it's headed. Because if you finish your graph at the top or the bottom, you have to curve them back down because that's the direction they're going. Okay, so that's kind of the visual of what is happening when we place those multipliers there. Okay, moving on to the next example. Okay, another cosine graph. So if I look at what's happening here, we have a reflection, a stretch, and a horizontal shift. So that negative sign out front is going to change all the y values. Well, if you change all the y values, you're going over the x-axis. The 2 is going to vertically stretch it by 2, which is what we just did. And then with transformations, whenever you add or subtract something to x, that is a horizontal shift. So here's our x-axis reflection. This is a vertical stretch by 2, and then right pi over 2. Okay, so let's look at what the parent function for cosine looks like. So originally we were labeled by these values. Okay, so and then our original points, cosine started right here, here, down here, here, and here. So let's take these points and apply these transformations, and then we'll fill in the rest. Okay, so remember we stretch and reflect first, and then we shift. So starting with this point right here, if I reflect over the x-axis, I am down here. And then if I stretch -1, if I double that, I'm at -2. So I've taken care of these two transformations, and here I am. I now need to go right pi over 2. Well, the good thing is this is what my scaling is by. So we're counting by pi over 2's. So if I take where I am and I shift, I'm sitting right there at pi over 2. Now if I take this point, if I reflect over the x-axis, it doesn't do anything because I'm sitting on the x-axis. If I double my y value here, y is 0. If you double 0, you're still at 0. So I just shift to pi over 2. This point, I reflect over the x-axis. I stretch by 2, and then I go right pi over 2. So I land right there. Looking at this point right here, again, we're sitting on the x-axis. The reflection, the stretch doesn't do anything, so I just shift it pi over 2. This point right here, if I reflect it, I'm down here at -1, and then if I stretch by -2, I'm right there. I then need to go over pi over 2. Well, if I'm counting by pi over 2, this would turn into 5 pi over 2. And so we have these points right here. Okay, and then this one I'm going to curve back up because we ended on a bottom point. Okay, so let me just add some more points. I started at the bottom. If you kind of look at this, that's our middle line, there's our top line, and there's our bottom line. We'll really get into this tomorrow, but those points are going to fall on one of those 3 lines that we place. So I ended at the bottom, so my next point needs to go to the middle, and then I need to go back up to the top, and I'd be at -pi over 2, -pi, -3 pi over 2. Because we don't need that -2 pi, because since we added a point there. So then I'm back to the middle, and then back down. There we go. And there's our graph of -2 cosine x minus pi over 2.